Welcome to EugeneCad.org, the home of Eugene web applications. EugeneCad is an ecosystem of languages tailored for rule-based design of synthetic biological systems, devices, parts, and DNA sequences. Let's have a look at the first app, miniEugene. miniEugene is a subset of the Eugene language and offers only constraints, namely constraints for the structure of synthetic biological systems under design. Here, we provide an example. We specify that the length of the design should be 1 and the design contains a P. However, the definition of P is not restricted. It is really up to the user what a P means. For example, P could stand for promoter, it could stand for a specific device, or it could stand for a part type. We are very agnostic to the level of abstraction of P. Let's have a look at the how-to of miniEugene, the documentation. miniEugene offers very many primitive constraints which are divided into counting, positioning, pairing, orientation, and interaction constraints. Counting constraints restrict the number of occurrences of genetic designs. Positioning constraints restrict or ensure the location of the occurrences of genetic elements in a design. Pairing constraints restrict pairwise occurrences as well as their positioning in genetic designs. Orientation constraints restrict the orientation either forward or reverse. And interaction constraints constrain regulatory interactions among components in a genetic design. Now, let's do an example together. We want to build a basic transcriptional unit consisting of a promoter, RDS, gene, and terminator exactly in this order. Therefore, we select the length of the design to 4. We specify that it contains a promoter. Let's call it P. Next, we also specify that it exactly contains one terminator. Let's call the terminator T. And we are already specifying that the gene G always comes with an R. Now, let's see what miniEugene generates. At the right, miniEugene visualizes all constraint-compliant solutions using ASPOL visual compliant symbols using Pigeon. As you can see, the parts are arranged in various variations as well as in various orientations. Let's enforce miniEugene to only generate designs containing forward-oriented parts. Therefore, we use the all-forward constraint, and as a result, we are getting designs that are consisting only forward-oriented parts. Let's have a look at the statistics. The design space is 4096, meaning that there are 4096 possible solutions. However, with those specified constraints, miniEugene prunes the number of solutions to 24. Now, let's constrain the positioning of the elements P, T, G, and R. Let's say that a transcriptional unit starts with the promoter P, it ends with the terminator T, and that the RBS R is placed before the gene G. And miniEugene finds the only rule-compliant design. Now, there's a little task for you. Can you specify the design to your right?